Welcome to Lesson 14 of Course 2. This lesson deals with problems about parts of a whole. It also deals with just simple probability. We're going to solve and write one-step word problems about parts of a whole. We're going to write equations for word problems about parts of a whole. And then we're going to find the probability of a simple event. There is no additional vocabulary for this lesson, so again, continue to study those vocabulary words that you already have and commit them to memory, please. So let's start about talking about problems with parts of a whole. It's like if you take an apple and you break it up, or a pizza and break it up into parts, several parts make up the whole. In our example here, it just states that a part plus a part equals a whole, or A plus B equals W. For example 1, if 1/3 of the students attend the game, what fractions of the students did not attend the game? I like to take these, and I recommend you do that too, and do it with pictures. You don't have to, but if I have this represents the game, and we divide this up into thirds, and 1/3 of the students attended the game, how many thirds did not attend the game? See if you can figure that out. We're not given the number of students, so we're given the fraction of students in the whole class, and they've done the same thing here. They've drawn the same pie chart that I did, breaking it up into thirds. The way we solve that is we take the part, which is the 1/3, and we know the whole is 3/3, or 1. This equals 1, but when we break it up into thirds, doesn't 3/3 also equal 1, or the whole? Sure it does. So all we have to do is find out this missing part here, and we all know that missing part is 2/3. Melissenda's science beaker is 61% full. What percent of Melissenda's beaker is empty? I think everyone can do this. Please go ahead and calculate this and then restart the video. We know that if she has a full beaker, or a full-size beaker, and it is 61% full, we know from subtraction that the empty part would be 39%. And we verify that just by adding the two together, 61 plus 39, to verify that it is 100%. So we know that our answer for what percent of Melissenda's beaker is empty is 39%. Probability is the likelihood that a particular event is going to occur, and it'll fall between 0 and 1. 1 meaning that it's certain that it'll happen, and a 0 meaning that there's no way that it's ever going to happen. And then there's everything in between. If it's halfway, if the odds are 1/2, then it's equal, that it could occur, it couldn't occur. This is like flipping a coin. It's 50-50 chance is 1/2 of a coin. So a coin, flipping a coin, is really, it's equally likely it's going to be heads as it is going to be tails. If it's less than 1/2, then it's less likely to happen, and if it's more than 1/2, then it's more likely to happen. The thing to remember is that the formula for probability is the number of favorable outcomes divided by or over the number of possible outcomes. So let's look at a few of these. So remembering that the number of favorable outcomes over the total number of possible outcomes, let's look at a bag of marbles. Suppose we have this bag of marbles, and inside this bag there's 9 marbles. 4 of those marbles are red. 5 of those marbles are blue. That's what gives us the 9 marbles total. So if it asks us how can we find the probability of picking each color, to figure out the red marbles, we know we have favorable outcomes are 4, that if we were to pull out marbles out of that bag, that eventually we'd pull out 4 and out of 9 marbles total. So our probability of pulling out 1 red marble would be 4 out of 9. In contrast to that with blue, because there's 5 blue marbles in there, our odds of reaching the bag and pulling out a blue marble would be 5/9, would be our probability. Because we've got 9 marbles in there, 5 of them are blue. So obviously, so tell me this. If these are the numbers, and I hand you the bag, and I ask you, what color are you most likely to pull out of the bag? What color would you tell me is the color you're probably going to pull out? Hopefully you would say blue, because blue has a higher probability than red does. There's 5 blue marbles in there. There's only 4 red ones. This cube, number cube, or all number cubes, have 1 to 6 dots on the faces of the cube. If the number cube's rolled once, what's the probability of each of the particular outcomes that they asked for here? What's the probability of rolling a 4? How many times does 4 show up on this cube? It only shows up 1 time. So favorable outcome is 1, because it can only show up once, out of how many total outcomes? Well, there's 6 sides to the dice. So the answer to A is going to be 1/6. The probability of rolling a 4 is 1/6. Go ahead and work these other 3 and see if you can come up with the answers. Then let's check them. Restart the video. Our chance of rolling a number greater than 4, you've got 2 numbers greater than 4, 5 and 6. So that'd be 2 out of 6 would be our probability, or 1/3. Rolling a number greater than 6, there's only 1 number greater than 6, and that number would be 7. So that would be 1 out of 6. Or 0 out of 6, I'm sorry. There's only 6 sides to the number cube, not 7. So the probability of rolling anything larger than this 6 would be 0, absolutely no probability, because it only goes to 6, so you can't roll anything larger than a 6. And rolling a number less than 7, well, all the numbers on a cube are less than 7, so your probability of doing that would be 6 out of 6, or 1. Now let's look at a spinner. This spinner is divided into 5 equal parts, and we spin it once. How many different outcomes are possible? 5, right? Because there's 5 spots that it could land on. What's the probability of spinning a 3? How many times does 3 show up on that spinner? Well, it only shows up 1 time. So 1 favorable outcome out of how many? 5. So our probability of spinning a 3 would be 1/5. What's the probability then of not spinning a 3? Hopefully you came up with 4/5. And all of this just explains everything that we just did. Favorable outcomes over total outcomes possible. Now let's look at a spinner that's broken up not into equal parts. In this case here, the right side is divided into 1/2, and then we have 2/4 to make up the whole. So what's the probability of a spinner stopping on a 3? Go ahead and figure that out, and let's see if you can get it right. Well, there's 3 possible outcomes, but the outcomes are not equally likely. This here, first of all, is 1/2, and it equals 1/2. So probability of landing on a 1 would be 1/2. Probability of landing on a 2 or a 3 would be 1/4, or 1/4, or 25%. But it'd be 1/4 because this 3 represents 1/4 of the total circle. Here's a written practice. Your ticket's in the door. Please do problems 5, 6, 16, and 29. If you have any questions, give me a call on the phone. Other than that, if it's not an emergency, just wait tomorrow. We'll work on them in class. Thanks for watching the video.